Hello, teachers. Just wanted to reach out with another math moment. I had this idea a few weeks back, maybe even a month or so ago, but haven't had time to execute it. I want to talk a little bit about classifying numbers and the importance of students being able to classify numbers. I saw this in a teacher's classroom, going over rational, irrational numbers and those types of things, and just thought about the importance that students be able to identify that, and primarily because the rules for the numbers are different as we get into higher level maths. Specifically, what it means for a number to be simplified is very important. So, rational numbers, and for example, if we have 5 over 10, 18 over 36, 2 over 4, 1/2. Of course, we know that all of these are equivalent values, but rational numbers are said to be simplified if the numerator and denominator do not have a common factor. So rational numbers, it's really easy to kind of identify. The rules for simplifying a rational number is that you have to eliminate common factors from numerator and denominator to get into a simplified form. As we move up the numbers, we deal with irrational numbers. For example, we have an irrational number like 1 plus, let me switch that over, 1 plus the square root of 6 over the square root of 2 is the same as square root of 2 plus 2 square roots of 3 over 2. It's the same as square root of 2 over 2 plus the square root of 3. So these are all equivalent values. We could argue that both of these, the second two, are in standard form or simplified form, and we've got to know the rules for simplifying irrational numbers. So getting students to identify irrational numbers and then know the rules for simplifying irrational numbers. Of course, those rules are we can't have a perfect square factor underneath a radical, and we don't like to have radicals in the denominator. So that's the two rules for simplifying irrational numbers. And then when we get into Algebra 2 and beyond, then we start talking about complex numbers. Complex numbers are simplified if they are in A plus BI form. So complex numbers have a few more rules, but complex numbers can be even a little bit more difficult to identify as being equivalent or not equivalent. All three of these complex numbers are equivalent. Of course, this is the only one of the complex numbers that is in simplified form or standard form in A plus BI format. So just using the language, it's early on in our mathematical lives. It's very important for students to be able to identify the different types of numbers. That's very important because we want them to identify early, so a little bit later they can learn the rules for simplifying. So as soon as they see a irrational number, they hopefully they will recall the rules for simplifying. So just a little bit of a little short lesson there to kind of help us standardize our language. When we're dealing with irrational numbers, instead of calling them, the square root of 3 over the square root of 2, for example, instead of saying we've got to rationalize the denominator, let's refer to this as an irrational number that has to be simplified, and then learning the rules for simplifying irrational numbers or putting them into a standard form, and then on to complex numbers as we move into the higher maths, learning the rules for simplifying complex numbers and putting them into standard form. Just some thoughts. Hope you guys are having a great day. Talk to you later.